Assalamualaikum and very good morning to all. My name is Fakhrul bin Idris. My metric number is M12242001. So I would like to present the research proposal for my master project. So the title is Development of Microstrip Array Antenna at a 6 GHz fixed wireless access band for point-to-point rural community internet solutions. So a bit of background of this project. So fixed wireless access is a solution for delivering high-speed broadband to underserved rural area without relying on costly and difficult to deploy wired infrastructures. With the growing demands for connectivity and the development of 5G networks, so the C-band frequency spectrum, particularly at the 6 GHz, can be identified as a suitable candidate to support the FWA services in Malaysia. This presentation will cover few topics, mainly the problem statement, research scope, then research objective. I will list out the literature review, the methodology that I'm going to use, and the expected outcomes. We will discuss the milestone and the conclusions and also the references. There will be the Q&A sessions at the end. So the first of all, the problem statements. Currently, there's a significant digital gap between the rural and urban area in Malaysia in terms of the broadband internet services adoptions. So the current broadband solutions such as fiber optics are often impractical, costly, and very high maintenance costs. So the implementation of fixed wireless access is the best, but it requires a new antenna designs to support point-to-point or point-to-multiple point nodes between communication between nodes and user. The research scope for these studies, basically the 6 GHz antenna will be developed using the microstrip patch and simulated using the software CST, and 3 samples of the single and array antennas will be fabricated each and be tested using the lab equipment in the lab. So the research question that I'm looking for is how does the dielectric constant of the dielectric FR4 will affect the radiation pattern and the gain of the antenna. And then when we compare the advantage or limitation between the difference between the single type antenna and the array type of antenna, which one will actually give the best antenna performance? The research objective basically is to design a C-band 6 GHz array directional antenna for the 5G fixed wireless access applications. From the design, we will optimize the antenna dimension to get the best antenna performance based on the simulation results. So once we finalize the antenna dimension, the antenna will be fabricated and measurement testing will be done to determine the antenna performance such as return loss, VSWR, the radiation pattern, the peak gain, directivity, and also the bandwidth. Next on the literature review, so the potential usage of 5G fixed wireless access to bridge the digital gap, even though we may need to reallocate certain portions of the C-band that are currently used by the satellite services. And we found out that the microstrip type of antenna are offering the best design flexibility, and it allows multi-band and wideband operations and can be integrated using the array for the 6 GHz and support the 5G system. This comparison table shows the previous antenna studies on C-band frequency that have been identified and classified into resonant frequency dielectric substrates used, antenna type designed, feeding technique choice, and type of development. So based on this, the choice of type of dielectric substrates and the feeding technique have been finalized. The methodology that I'm going to use for this research is basically design the antenna using the CST software, which involve the theoretical formula to calculate the dimension of the antenna. Once the simulation is ready, I will run the simulations to determine the parameters of the antenna and to get the best optimized parameters. And then the antenna will be fabricated using the photolithography and chemical etching processes in the lab. And finally, the parameter measurements using the fabricated antenna will be done in the laboratory using the equipments provided. This research project expected outcome will be the antenna design dimensions, the antenna parameters, basically the three parameters, which is return loss, the VSWR, and the gain. So the expected parameters are listed in the table here for single patch, so 1 times 2 patch array and 2 times 2 patch array antenna. Next, this is the milestone and the timeline for the project. So the antenna design part will require 3 months to complete, and the antenna optimizations will be done in the next 3 months or so. So I require 3 months to complete the antenna fabrications, and finally another 3 months for the antenna testings. In conclusions, a critical research gap identified is the absence of optimized antenna design, especially targeted for the 6 GHz operation in the rural fixed wireless access services. This project aimed to bridge that gap by designing, stimulating, and fabricating a microstrip patch array antenna that meet the key performance metrics, including low return loss, acceptable VSWR, adequate gain, and stable radiation characteristic. It contributes to technical knowledge in the field of antenna design. By having a reliable wireless connectivity, the project can support the broader national goals of digital inclusions and rural development. Finally, for the Q&A sessions, the first question: what is the main contribution of your research? So single and array antenna design that can be used in the fixed wireless services with the expected output parameters, which can be replicated and tested by others. For the second questions, what are the impact of your research to the industries and communities? For the industry impact, telecommunication company can start implementing fixed wireless access at the 6 GHz antenna using the proposed antenna design. And for the community impact, if the take-up or rollout of the fixed wireless access services, they can have a rural internet services which can be delivered using the antenna design. These are the list of full references that I use in the research proposal. So that's all. Thank you.